they can be used to trade value. The typical transaction workflow for blockchain is users, they submit transactions, they pay the fees for those transactions to the network. The network aggregates those into blocks and sends for validation. The miners and validators, they validate that block that is added to the blockchain, and then the fees plus usually a premium is paid to those miners and the validators. The blockchain also runs applications, and those are called smart contracts. They are distributed, decentralized, automated applications that run on top of the blockchain. An example could be a smart contract that is used to track fulfillment from the warehouse all the way to the household of the customer. Other use cases include digital identity management, securities, include supply chain, food sourcing, any use case where a trusted ledger of information is required. Ethereum is a blockchain implementation focused on enabling the development of decentralized applications. It implements a Turing-complete virtual machine for the execution of code. It also defined a cryptocurrency called Ether. Smart contracts in Ethereum, they are written in specialized languages like Solidity and Serpent. They are deployed into the Ethereum network. When they do, they receive an address. That address is like any wallet for a user. In all interactions with smart contracts, they are transactions. Because all transactions in a blockchain cost money, in quotes there, all interactions with the smart contract that change state are also transactions. The cost is fixed in a unit called gas, but it's variable in Ether. Ethereum defines a variable hard limit on the cost of transactions. If you hit that limit, the transaction is aborted and rolled back. This helps prevent attacks or mistakes in the network, keeps the stability. Another concept is that Ethereum is a sandbox. That means that all smart contracts running on top of Ethereum have no direct access to external services like we're talking about web services and APIs, market data, streams of events from IoT devices and things like this. Oracle is a concept of an asynchronous interface that was created to help solve this problem. Among other things, this is just one of the reasons. Typically, contracts in real world, they are very complex, hundreds of clauses, so translating them into a programming language like Solidity requires quite a lot of code and becomes quite complex quite fast. There is a problem because everything in the network is immutable, so once you deploy a smart contract, it will be immutable. That's good for clarity and safety, but for volatile parts of the contract, the logic of the contract, it becomes a problem. It's impossible to update. DMN can help on some of those cases because it defines a standard language, higher level language to define business logic that can be understood by all parties involved in the operation of a smart contract. And here is a quick high-level diagram. So you have the client applications that can be, for instance, BPM processes like defined and presented this morning by Vanessa. Smart contracts are in the middle and the DMN services are in the back. More information on those links, and also, as Brooke said, we just published a book. I wrote one chapter of that book just about blockchain and about the example that we'll talk here today. Whew. Thank you for making me learn to speak fast in English. Okay, so first I just would like to make a quick disclaimer. So how this come about? Last year, Bruce, I think it was Bruce or Denis, you guys pointed me to this paper here, to this article. It's a blog post by Paul Chance, and I don't know who he is. I should have done my research. But he makes some interesting points here. One of them is that one obstacle that exists in fulfilling the vision of trustless smart contracts is the requirement for execution rules that are transparent to all participants. And as we will see, Solidity and the other languages for smart contracts, they are not so transparent like that. So he writes a question here. So a visual model such as BPMN and or DMN could be used to generate the contract source code via the process engine or the DMN engine, right? So I thought, the nerd in me thought, look, there is a problem. Let's take a look. Let's try to investigate this a bit better. Is it possible to use BPMN or DMN to create smart contracts or to interact with them? And this is what originates this presentation and the discussion that we make in the book. I will cheat a little bit on the on the presentation here. I just need to show you the use case, what it is. The use case is a land registry office. So when as you know, I'm talking here about Canada, but it's probably the same everywhere else in the world. You have the land registry offices, and they have to track the transactions that go on with a property. So what we will do here is create a smart contract that will manage the settlement of transactions with properties like someone buying and selling. The goal is to provide reliable information about property ownership, prevent frauds, reduce cost, and etc. So what I will show today is one transaction, that is the sale of a property, where the seller initiates the transaction saying, I agree to sell this property to this buyer by that amount of money. The buyer submits his information to the contract. The contract will do the settlement, but instead of hard coding the rules, especially legislation that is defined by government and can change at any time, it will use the Oracle to invoke this service as an external DMN service, receive the response with all the amounts involved for the settlement, and then the buyer can submit the payment, and the contract will do the settlement. The other thing to highlight is Vanessa presented this morning this part here. That is basically the front end, so BPM processes interacting with smart contracts to do the transactions. This is not my focus of the presentation, so it was good because now we have the two sides of the coin here. We have a complementary discussion. My focus here is really into the smart contracts, how they interact with the DMN services. You will, however, have the chance to see my great awesome skills in developing crappy web applications to interact, because I will use a web application just to drive the example. So first thing to show is, okay, so we have these rules about legislation about the market, and here I'm using as example Toronto and the province of Ontario in Canada. So there are some rules about taxes that you have to pay to the province, or when the mortgage insurance is mandatory, when it's optional, how much you have to pay, and etc. And I encoded those into a DMN model that, as you will realize soon, it's much easier, much simpler to understand than code in Solidity. This is also better because you can show this to business, and business is talking to you in the same language, right? So here just, calculates base amount, and then for instance, in Ontario, there is a rebate in case of, a property that is sold in Ontario with a buyer that is at least 18 years old, that is a Canadian citizen, that is a first-time buyer, and the maximum amount is $4,000, and etc. And here at the bottom, a very easy example of how this logic can change. I'm not sure if you can see that, but last year the province imposed a tax for foreign buyers of properties of 15%. And this is the kind of thing that you can't predict in advance in the system, right? We are talking about contracts here that will be decades in place running there, that are quote unquote immutable, right? And out of nowhere, the province says, well, I have to cool down the market, so I'll create a new rule, right? What that would force is, if this solution was in place with pure smart contracts without DMN, what would happen is you would have to basically create new versions of all the contracts, because each each property is one instance of the contract, and then you have to migrate the data from, how many million properties you have in the province to the new version of the contract. That's very costly, right? So this volatile logic that is, it's not distributed. This is defined by the government, so the government can provide a service, a centralized service to provide that information. So this is what this DMN model represents. Obviously, it's a simplification. It's simple enough to understand, but it's complex enough to show the potential. So what I did was I deployed this as a service. I deployed into the Red Hat server, DMN server. So we can see here that it's running in my machine just to make sure with closing the laptop and stuff that everything is running. We can see here a quick call to the REST API saying, yeah, the server is running. Actually, this model is in there with all the decisions and etc. Right? We can execute this this model just to check the results. So here are some parameters, and I can execute this and see, yeah, it is indeed running there. Here are the results with the calculations. So we are good to go. So the other part of this demo is the contract itself. So I'll just show you here. I've set up 6 accounts in the blockchain node that I'm running here. And you can see the first account here. We'll see this, but it's the government. It has all the money, as you know, the government does. And then you have, a seller that starts with 10 Ether, a buyer with, a ton of money, and then accounts for the province, for the city, and for the insurer, the Canadian Mortgage Insurance Company. Okay. So the Solidity code. So this is the smart contract, and Vanessa presented this environment this morning. Thank you, this helps, so I can skip that. But the contract itself, I connected to the instance that is running here. And the contract itself has quite a lot of code, and I will emphasize that right now what this code has is basically it stores data and invokes, generates events and services. The actual logic for this contract is externalized to that DMN service. The other thing that I will talk after my demo is about where BPMN can play some role. As you can see, if I am not using BPMN, the contract itself has a workflow, and this workflow is emulated here by this state variable that keeps changing depending on which state it is, right? So this is one place where plugging a front end like Vanessa presented this morning with BPM, it helps a lot. It was not the goal of my demo, but I want to emphasize the importance of that. So the first step in this little demo is that we have a property that is registered by the province, so the province registered this. So there is a property contract here on this address. I am pre-populating some of the fields here to make it faster. And then I can see, I could see all the data from that property. Here I'm just using, for example, the address and the owner. So the owner is here, and here is the address of the property. And so I want, as the seller, let's say I'm the seller, I logged into the system, and I'm now starting a sale. I'm agreed to sell to this buyer here, so let's call him the CC3 buyer, for a given price and a given Ether exchange rate, because we will manage this all within the Ethereum network. So we have to agree on a exchange rate for Ethereum that we'll use for our sale. So once I initiate the sale, basically what happened is that method, that function in the contract was executed. It stored some information, and if we look here at the state is now 1. 1 means it's a sale initiated process. After the sale is initiated, then the next step in our flow, the buyer goes there, logs into the system, and says, I agreed to buy. Here is my information. John Smith, 35 years old. I am, buying this. I'm doing, making a down payment of 200,000 of the 500. Here is my information, and he will submit the information. So when he submits the information, it basically executes a function in the contract that only the buyer can execute that will store some information in the contract itself. But the important part is it actually fires an event. This calculate taxes is how Solidity talks to the external world through oracles. So it fires this event. There is an oracle that's listening to that event that will invoke the DMN service and populate the results by calling the set tax amount. Because this is all automated, I will not be able to show you in between the steps, but we can see here, for instance, that the prospective sale is set, but the buyer did not submit the information yet. So as the buyer, let's submit the information. It generated the event, calculated the result, and is coming back with the result. So calculated the sale price, the taxes for the province and city. In this particular case, it's not mandatory to have insurance. Here is the total amount. And if we look at what happened to the contract, now we have a prospective buyer with that information. The taxes were calculated. Here are the tax amounts that have to be paid. The current state of the contract is 3, so it's waiting finalization, and that's how. And that's now what the buyer will do. Once he clicks here, he is actually paying money. So he had 10,000 Ether minus the transaction cost. Actually, let me show you this because it's interesting. As I said, all transactions in the network interacting with the contract cost money. So you see that the buyer started with 10,000 Ether, but now he has a little shy of that because he was interacting with the contract. But now he will pay, and just for easy of calculation, we said the exchange rate to Ether is 1,000. So 500,000 will be 500 Ether. So he will transfer 500 Ether to that seller. So once he clicks to finalize the sale is done. So now, if we look at the state is back to wound, is back to 0. And I didn't show you before the owner, but the owner now is 663. So if I go back to my little app there, and the previous owner was this 823 here, and if I check again now, the owner is 663. So this is just a quick run through of the example to show you the actual transaction working. There are a couple notes that I would like to make about this presentation. The first one is, again, to emphasize how this complements what we were talking this morning in BPM. So that flow that was actually hard-coded, simulated into the smart contract, it doesn't need to be. That flow could be managed by a BPM process external, and that would be much easier for users to understand, right? So the point of using this, BPM, DMN, CMMN standards, for me, the ability that those standards give you to talk the same language among different teams is it's like the value of those standards by themselves. Everything else is just additional value. It's what makes those standards so good. The other thing I would like to emphasize is that both these technologies, DMN and smart contracts, Ethereum blockchain, they are emerging technologies, and they are changing daily. Ethereum is not fully implemented. I think the schedule is like for next year to finish the implementation. So right now is the time for us to investigate this very promising blockchain technology and understand if those promises will become reality, and for us to help shape that reality, for us to help see where that can be used and where we have advantages in using that. Same thing for DMN. We have version 1.1. We are about to release version 1.2, and where do we go from there, right? The third point that I would like to make is this kind of architecture, it really couples or really matches the trend that we have in nowadays in containerization and microservices. DMN as stateless decision services, they really lend themselves to a deployment architecture that emphasizes, that potentializes the value with that. Smart contracts, they run in distributed networks by themselves, and they can easily communicate with those services, and it makes for a very easy solution. And my final point is just a disclaimer. Obviously, everything that I showed here, I was concerned in exploring the technology. I was not concerned in, the cryptography, the privacy, the security of the data. So you see, I didn't log in or anywhere. I just created a simple driver of the application. But that's also a big concern that needs solutions. Some of them were discussed this morning, but there are more, especially on the decision side as well. For instance, if I have a contract calling a decision service, I need to make sure that I have, a signature of that decision service, that I have, a versioning of that decision service, because as this transaction is later, replicated in other nodes, I need to be able to replicate and verify the results. So that was it. I hope I didn't run too fast. Thank you. And questions? Bruce?
So, can you talk a little more about the oracles? So you wrote your own oracle, but there's commercial oracles. And I guess my question is, would it be useful for someone to create an oracle specifically for DMN, and, optimized for DMN?
Yeah,
that's something Red Hat in consensus would want to do.
It's a very good question. So Oracle is that listener service. So at the heart, on Oracle is very simple. Okay. So if I look at this particular example, and I look at the Oracle that I created, is really, really simple. And I will caveat this in a moment. So here is the oracle that I created. Of course, I have some helper methods there, but basically what it does is it receives an event, so it parses that event, and then with the values that it parsed, it will invoke. It will parse the response into like a better type. So parse the event, and then it invokes the DMN service, and then based on the DMN service, it invokes the contract back. So it's very simple. So the concept of oracles is very simple, but when we go to do this in real world, that's not the case. As I said, we need cryptography, we need signature, we need verification, we need caching. It needs to be high available because you have multiple nodes processing those transactions. So it's really a product in itself. The good news is for the public network, there is some companies, there are some companies that develop this. Oracleize It is one, and there are a few others that provide all those features, so you can just get a signature and use their services directly. For private networks, and for instance, one case that we discussed in the book as well, Swift. Last year did a proof of concept with 30 different financial institutions worldwide for doing settlement of transactions internationally. And that run on a private network. And for those cases, I believe it is possible and feasible to develop a custom oracle that does only that. Regarding your question about product, at the moment I'm not aware of Red Hat pursuing any particular product in blockchain area. My personal interest is in to promote the use and show how it can be used together, how it can be integrated. I can talk about consensus, maybe they're in that area as well. But thank you. Yeah.
Yeah, just to note, and this is probably a question for both of you.
Yeah, so I have, right now I'm running test RPC because, as I said during lunch, I do have a private network here, private blockchain, Ethereum blockchain, but because of the proof of work algorithm, when I run it, it shuts down my laptop. So, I can demonstrate if someone is interested in looking at a private actual node running, I can show you. But this is running a test RPC that's a tool for development that simulates a node without doing all the validation work. Other questions? Okay, thank you very much.